All right, if we have word problems or modeling problems, real-world problems that deal with decay, we can use this equation. So exponential decay occurs when something's decreasing at a constant percent. So constant percent of decrease over time. So we have a equals little a, 1 minus r to the t. This should look super duper familiar from when we did exponential growth. When we did exponential growth, it was a plus sign. Exponential growth is a minus sign because it's decaying. We're losing something. Okay, a, the little a is still the initial amount, however much you started with. R is still the percent decrease. Make sure you move in the decimal point. So if it's a 5% decrease, you're putting in 0.05. And t is the time. T is, could be years, minutes, hours. It just depends on the problem. Okay, but the key is the minus sign. So we'll check out an example. A cup of tea contains 35 milligrams of caffeine. That's how much it has. We're starting with, that is our small a. The average teen can eliminate approximately 12.5% of the caffeine from their system per hour. That's our rate, which of course we have to rewrite as 0.125. And notice we are eliminating, which means we're decreasing. Okay, the amount of caffeine in your body is going down, so this is a decay function. So we want to write a function given the amount of caffeine in a teen's system after t hours, and then use it to find the amount of caffeine after 3 hours. So first we're going to write our function. So our initial amount is 35. When you drink this cup of tea, you have taken in 35 milligrams of caffeine. And we have 1 minus 12.5% to the t. So what's this saying? This is saying is that every hour, 12% of that caffeine has been eliminated by your body. Okay, it's this constant process. Now we can go ahead and do this subtraction that's in the parentheses. So we get 35.875 to the t. Okay, we cannot multiply the 35 times 0.875 because that is being raised to the exponent. So order of operations, we can't multiply, just leave it that way. Another way to think about this is that every hour you have 87.5% of the caffeine remaining in your body because you've lost 12.5%. All right, so this is our function, and now we want to use it to find the amount of caffeine in your body after 3 hours. So we have 35.875 to the 3, okay? You can put it all into your calculator just like this. Your calculator knows order of operations. Just make sure if you're like doing it by hand or whatever, you have to do the exponent first, then multiply by 35. Anyway, when you put it all in your calculator, I think we end up with like 14.8 milligrams. So this 35 milligrams of caffeine that you started with, after 3 hours, you're down to 14.8 milligrams. Okay, so things that use decay, things that lose value, like cars, like you buy a car and it depreciates in value over time. Drugs, like if you're any type of drug, like caffeine, aspirin, like you take something and your body's gradually absorbing it, that's going to be a decay. Radioactive elements, things that are radioactive, decay at a certain rate. Okay, so we'll see a lot of word problems about those. But next you're going to do the try it problems.